Solving inequalities. You're watching this video with Ms.Y. Cavazos. In this video, you're going to learn how to solve inequalities, which really, it's not anything different than solving equations. We still use the same steps. We still use inverse operations, and just quick recap. The inverse of addition is subtraction. The inverse of subtraction is addition. The inverse of multiplication, of course, is division, and the inverse of division is multiplication. So we still need that. It's very important. We're still isolating the variable. We're trying to get that variable by itself. So the only thing is, once we obtain our answer, there's going to be one tiny detail that we add because we're working with inequalities. So inequalities, again, in case you forget, is the less than symbol, greater than symbol, less than equal to, or greater than equal to. What I'm going to do here is I'm going to write a few statements, and I'm going to do something with these statements so we can understand what happens with inequalities, because something unique happens. So I have this inequality that says 8 is greater than 3. Notice that the opening is towards the 3 because the 3 is greater. So what I'm going to do is I'm going to add an amount to the left hand side, and since I did it there, I have to be fair and I do it to the other side. So I have 8 plus 2 is 10, 3 plus 2 is 5. The inequality doesn't change, and we get that this amount is still greater than this amount. So this is still true. Even if you add a 3 on both sides, if you add a 4 on both sides, if you add any number on both sides, the left hand side is always going to be greater than the right hand side. Okay, well, what if we subtract? Let's suppose I wanted to subtract by 3 by 3. If I do it to one side, I gotta be fair and do it to the other. 4 minus 3 is 1. 7 minus 3 is 4. Bring down the less than, and again, this is less. This is pointing towards the 1. It's less. Sometimes we tend to get confused with the less than and greater than. The one that looks like an L, like a slanted, like a lazy L, that's your less than symbol. So 1 is still less than 4. So we can say that no matter what you subtract to both sides, but it has to be the same amount, this statement is still going to be true, always. So I have two other statements here. What I'm going to do now is I'm going to multiply or divide. So let's say I were to multiply by a 3. So parentheses 3. What I did to one side, I got to do it to the other. 2 times 3 is 6. 5 times 3 is 15. So inequality doesn't change. Well, guess what? It's still a true statement. So no matter what we multiply, it's still going to be the same. Now, I shouldn't say no matter what we multiply by, because it is going to matter in a moment. What if I wanted to multiply by a negative 3? If I do it here, I must do it over here. 2 times negative 3 becomes negative 6. 5 times negative 3 becomes negative 15. If I bring down my less than symbol, the quantity negative 6 is not less than negative 15. That is false. So to make this statement true, I will need to rewrite my inequality the other way, where it states that negative 6 is greater than negative 15. Now let's check it out with dividing. So let's say I wanted to divide by 2 on both sides. 12 divided by 2 is 6. 8 divided by 2 is 4. Bring down the inequality. This is still true. 6 is greater than 4. It's a larger quantity. But what would happen if we would have divided by a negative 2? Would this change our result? 12 divided by negative 2 would give us a negative 6. 8 divided by negative 2 would give us a negative 4. And if we bring down inequality, negative 6 is not greater than negative 4. So what we need to do is flip the inequality to make it a true statement. Well, this brings us to today's main key thing to solving inequalities: multiplying and dividing. And I just showed you a couple of examples. By a negative value will always flip the inequality. So as we witnessed here, we divided by a -3, and in order to make this statement true, we had to flip the inequality. When we multiply by a positive, that wasn't the case. And here we divided by a positive, nothing changed. Once we divided by a negative number, we needed to flip this inequality to make it true. So, with that being said, we're going to continue to the extra detail that we're going to need for solving once we solve and obtain the answer. Inequalities. Number lines come with inequalities. So our number line is going to look like these 4 different options. We have 2 options for exclusive and we have 2 options for inclusive. What makes it different? Open circle, closed circle, and closed circle. So, this inequality, notice that it's pointing towards the right. So it says if we had a number line and we were focusing on a particular number, that particular number is going to be exclusive. You don't include it. Greater than means everything on this number line, everything shaded, is going to be towards the right. So that's how our number line will look like. This number line, notice that it's pointing towards the left. So that means if we had a number line and we were talking about a specific number, we would exclude the number because it has an open circle. It's less than, so we don't include it, but we include everything that is smaller than that particular number. Our next number line, again, if we were to have a solution of a particular value, this is a closed circle, which means you do include that value, and you're going to include that value and everything else that is greater. So we would shade towards the right. Same thing for this number line. We found the solution, it's a particular value. You're going to include that value. It's inclusive because it's less than or equal to, and you include everything else that is less than that value. So 4 different number lines. Let's give this a try. So this here says create a number line to graph the solution of each inequality. So this inequality is saying x greater than 7. Well, something we need to know about x is that it represents all real numbers. What that means is any number you can imagine as long as that number is greater than 7. So that's exactly what I'm going to draw in my number line. The number we're going to focus on is 7. Notice that this is just greater, so it means open circle. And notice that the 2 points here, the two openings, I guess you can say, are pointing towards the x. So that means this is greater than 7. So we need to shade towards the right because all of these numbers are going to be bigger than 7. 8, 9, 10, and so on and so forth. All those numbers are towards the right and they're greater, they're bigger. And I'm just going to add a little detail that this here is exclusive. We would not count the 7. And next, inequality. Let's say this was our solution. Notice this is not an equal sign anymore. It means this is kind of like a slanted L, so it means less than. So this is saying that you have a number line. You're going to focus on the -10. Because of this inequality, less than or equal to, it means inclusive. So you do include the 10, so we need an open circle. And we need all the numbers that are less. So all those numbers smaller than -10 are towards the left. They keep getting smaller and smaller towards that side. So that's how our number line would look like. And of course, the 10 is inclusive. you would include it. That's why we had to include an open circle. Next inequality here looks a little weird because the ones that we worked with, the variable was on the left hand side. So this here, I'm going to rewrite it, and you can. I want the variable on the left hand side, and I want the number, the value on the right hand side. Well, keep in mind that if I copy the inequality the way it is, it doesn't have the same meaning as it did here. And to paint you a picture, notice where the opening is at. So I'm going to draw a shark or a fish. This fish is eating the 2. So if I do the same idea here, draw my fish, this fish is eating the x. So it doesn't have the same meaning. That means, okay, we got to change the inequality. It has to flip over. If I try to draw my fish, is that fish pointing towards the 2, or is it trying to eat the 2? Yep. So now it has the same meaning as it did up here. So this is saying x, all real numbers. So x is all the numbers you can imagine as long as they're less than 2. So when we draw the number line, we're going to focus on the 2. And it's going to be open circle, which means exclusive. And we're going to shade all the numbers that are less, smaller, which are the numbers on the left hand side. So again, it would make the 2 exclusive. So that's the extra detail that we're going to need once we get our answer. Again, this is no longer x is equal to 2. Now we have inequalities, so we're going to need some kind of number line. So let's start. Solve each inequality and graph the solution on a number line. Here we have our variable, and it's on the left hand side, which is usually where we want to have it most of the time, or preferably always. So we need to move these two terms, or these two, values away from it. And the first one that's going to get moved over is the 14. So to eliminate the 14, we're doing the inverse operation. We're going to subtract it over. Okay, that doesn't look well. Subtracting it over, we move down the 2m. We bring down the inequality. 44 minus 14 is 30. The next step, well, divide by 2. Divide by 2, and we get that m is greater than 15. So I need a number line to represent my answer. So we're going to focus on 15, exclusive, so open circle, and notice that everything is pointing, the mouth is pointing over to the m, which means m is greater. So all the numbers bigger than 15 are on the right hand side. So I would just color in my number line towards the right hand side. And that's it. That's our final answer. Okay. Let's try this other problem. We have our variable here. We have a minus 4 multiplying the variable, and we have the 26 that is adding the variable. So PEMDAS, when we go backwards, we need to get rid of whatever is adding or subtracting first, the variable. So we're going to move the 26 over by eliminating and doing the inverse operation, which is minus. So that cancels. Bring down the minus, don't forget the minus 4x with the inequality, and we get that 50 minus 26, 24. So next, we need to get rid of the negative 44 that is multiplying x. So we're going to divide by negative 4 because they are inverses. Now remember, we divided by a negative coefficient of x. So that means you have to flip the inequality. And earlier in the video I explained why that happens. So we just got to make sure that anytime we divide by a negative coefficient, this inequality has to flip. So we get our answer of negative 6, which, by the way, this number line does not seem to make sense, so I'm going to ignore it. Let's pretend it's not there. And that's okay, we'll just draw our own number line. So all we need is a negative 6. The negative 6, it's inclusive, so close circle. We need all the numbers that are less than negative 6, and all those numbers are towards the left, and that's our number line. Okay, let's try a few more problems. So now these problems are starting to look like the ones we did for solving equations. This next problem has variables on the opposite side of this inequality. So it's the same idea as if it was the equal sign. I'm just going to draw my line. I'm going to move this variable towards the left because I want to keep them on the left hand side. And I'm going to eliminate it by doing the inverse. So I'm going to add it over since it's subtracting. So it cancels. 3 plus 6 is 9n. So don't forget the n. Bring down the 4. Bring down the inequality. And bring down the minus 50. We're going to isolate the variable. So first get rid of whatever's adding or subtracting. So we got to get rid of the 4 by subtracting it over. Then we're going to bring down the 9n, keep bringing down the same inequality. Negative 50 minus 4 is negative 54. And the last step, 99% of the time, is to divide. So we're going to divide by 9. Now careful, we did divide by 9, and we divided into a negative number. But that does not cause the inequality to flip. What would have flipped the inequality is if we would have divided by a negative coefficient, a negative 9. Then the inequality would flip to the other side. But we didn't divide by a negative coefficient. We just divided into a negative number. Oh well, we get a negative 6. So finally our number line says that negative 6 is exclusive, so open circle. And we need all the numbers that are less than negative 6, which are all the numbers towards the left. Next one, parentheses. Gotta remember that parentheses means to multiply. We're going to distribute the 2 and multiply it to the two terms inside. So 2 times 3x is 6x. 2 times 6 is positive 12, so plus 12. And then everything else, copy it over. Here is our variable. It's multiplying 6 and it's adding 12. So we need to get rid of whatever is adding or subtracting first. So we're going to eliminate the 12 by subtracting it over to the other side of the inequality. So I'm going to draw my line. We get our 12s cancel out, bring down the 6x, copy down the same inequality. Negative 42 minus 12, and we get negative 54. And our last step is to divide. So we get that x. Now remember the inequality, we did not divide by a negative coefficient. We just divided into a negative coefficient, into a negative value. So we get a negative answer, and that is okay. We're going to focus on the negative 9. It's inclusive, so we need a closed circle. And we need to shade the area where all the numbers are greater than negative 9. So all the numbers bigger are towards the right. Okay, not bad. Let's try a couple more. Again, we see parentheses. We're going to distribute. We're going to multiply. Negative 2 times 3 over 2 is negative 3y. Negative 2 times negative 3. Well, negative times a negative makes a positive. 2 times 3 is 6. Bring down the inequality. Bring down the minus 12. We need to isolate the variable. So the negative 3 is multiplying it. The 6 is adding it. We need to get rid of whatever is adding or subtracting first. So I'm going to subtract it over. This cancels. We bring down the inequality, the term, the inequality, and we get negative 18. Our last step is we divide by negative 3. Notice that I'm dividing by a negative coefficient. This is when we gotta flip the inequality. Negative divided by negative is positive. 18 divided by 3 is 6. So this is our solution. And now we just gotta graph it. So that means 6 is exclusive. We don't include it. And we're going to shade everything that is greater than 6. And that is towards the right hand side. Final problem. We're going to, again, multiply. We're going to distribute the 5. And we get negative 10x plus 45 is less than or equal to negative 5x. Now this problem is a little different because we have x variables on both sides. That usually never happens, and when it does, we got to put them together. So we're going to move over the minus 10x, so we're going to eliminate it by adding 10x to the other x. Cancel. We bring down the 45. We bring down the same inequality. Negative 5x plus 10x is 5x. Negative 5 plus 10 is the same thing as 10 minus 5, which gives you 5. And at the very end, we're going to divide by 5, divide by 5, and so we get 45 divided by 5 is 9, and 9 is less than all the numbers, than x. So again, this looks kind of weird because we're used to having the variable on the left hand side. Now you got to remember you can rewrite it. But if you rewrite it, that means we have to flip the inequality in order to have the same meaning that it had before. Draw the number line. We're going to focus on the 9. We include it so it's open, closed circle, sorry. And we need all the numbers that are greater than 9. If I draw my fish, the fish is eating what's bigger, which is x. So all those numbers bigger than 9 are on the right hand side. And this is how you solve inequalities. I hope this video helps you.